Hello and welcome to our final PowerPoint module for this semester. We're going to be covering parametric and non-parametric inferential statistics. Recall last week we talked about inferential statistics more broadly, and I said, well, I haven't really given you a sense of the test that you would use, the specific statistical test you would use in order to draw those inferences, or in order to actually get that p-value in the end, right? So that's what we're going to be doing this week. What kinds of inferential statistics could you use in bivariate analysis in order to draw conclusions about the relationships that exist in your analysis? That's what we're going to do this week. Here are our objectives for the week: introduce parametric and non-parametric inferential statistics, and identify when to use each statistical test that we go over. Okay, pretty straightforward. I expect that this module will take you about an hour. There are a couple of videos to watch, so it might take a little bit longer, but overall I think it'll take you an hour to complete. Here are your deliverables for this week. You have your PowerPoint module. That's, as usual, due Tuesday by 11:59 p.m. And you do not have any assignments due this Friday because remember, we pushed the due date for your full proposal by a week, right? So you don't have anything due this Friday, but do continue to work on your proposals so that you'll have them ready for the next Friday. Here's your opening question. What is the purpose of inferential statistics? So that's a bit of review from last week. When would you use a chi-square test? That is, what kinds of variables call for using a chi-square test? When would you use a t-test? Right? So these are going to be two types of inferential statistics that we'll discuss this week. So at this point, you can pause your PowerPoint module and answer this question on Inquire. I'm going to start this module with a bit of review. Okay, so remember that just a couple weeks ago we talked about bivariate tests of correlation. And we covered several types of bivariate statistical tests: Kramer's V, Spearman's Rho, Pearson's R, and Phi. I want you to recall that these are tests of correlation. And tests of correlation tell us about the strength or the magnitude of the relationship between two variables. It's important to distinguish between these tests of correlation and inferential statistics. In inferential statistics, we're testing how confident we are that the associations we find generalize to the population. Okay, so we're going to be talking about inferential statistics and specific tests, but I also do want you to have in the back of your mind these bivariate tests of correlation, because we utilize both. We just utilize them for different reasons. Next, just to briefly review inferential statistics. This is what we covered last week. We use inferential statistics to infer, hence inferential statistics, to infer whether the correlations we find in our sample are true for the population from which our sample was selected. To put this another way, we're determining how confident we can be that our findings are generalizable to the population from which our sample was drawn. We also introduced p-values last week, p-values being probability values, but I didn't tell you where these p-values come from or what specific statistical tests you would do to get a p-value. So that's what we're going to do this week. Our p-value indicates how confident we are that our findings can be generalized to the population. As I said, I didn't really tell you where we get our p-value from, but we need to run a statistical test. And these tests are ones that you can do in SPSS. Okay, so that's where we're going with this. Let's start to talk about those specific types of inferential statistical tests that we might use. We can break inferential statistics down into two general categories or types. We have parametric inferential statistics and non-parametric inferential statistics. I'm not going to get too far into the weeds with why we would use parametric versus non-parametric tests, but I will give you a bit of the basics. And just like we did with tests of correlation, the type of test that you use for inferential statistics depends on the types of variables that you have. So you can easily just kind of memorize what to do when. For inquiring minds, I'll tell you that parametric inferential statistics are run when you have at least one interval ratio variable in your bivariate analysis. And parametric here means that we are making some assumptions about the parameters of our interval ratio variable, hence the name parametric. Here are the assumptions that we're making. In parametric tests, we assume that we have what is called a normal distribution for our interval ratio variable. That means, as shown in the figure on the right side of this slide, this means that our mean, our median, and our mode are equal, right? They're at the peak of our distribution for our interval ratio variable, and we have symmetry on both sides of the distribution. Okay, so this is the normal distribution, and when we run parametric tests, we are assuming that our interval ratio variable is normally distributed. Again, the thing I want you to take away from this, or to know, is that you're going to use a parametric test when you have an interval ratio variable in your bivariate analysis. Now, there are plenty of examples that we can think of, plenty of situations where we aren't going to have an interval ratio variable in our analysis. And in this case, we're going to run a non-parametric test for inferential statistics. So if we, for example, have two nominal variables, or we have a nominal or an ordinal variable, this is when we're going to run non-parametric tests. There are specific tests that we're going to talk about that you can run in given situations. Just like with our test of correlation, you just have to know what types of variables you have to identify which parametric or non-parametric test you're going to use. Okay, so I'm going to stop there. There's a lot more we could talk about here, but I just want you to really know basically that there are these two different categories that we could think about when we are doing inferential statistics. So what are some examples of parametric inferential statistics? What are the specific tests that we could use? I'm going to give you two here, and it's quite possible that one of these is going to be relevant for your proposed research for this class. Remember that parametric inferential statistics are run when we have one interval ratio variable in our bivariate analysis. And these inferential statistics are testing for group differences. All right. We have two different tests here. One is a t-test. This is when we are comparing two means. And I'll give you an example of this in a moment. And then we also have an ANOVA, and it stands for analysis of variance. This is when we have three or more means that we are comparing. You would use a t-test when you have an interval ratio dependent variable and a dichotomous independent variable, right? And then we're comparing the means across those two groups in our dichotomous independent variable. For example, let's say we're looking at sex differences in height. That's just to give you a simple example. So we have males, females, and then we have height, which is our interval ratio dependent variable. In the figure on the right side of the slide, perhaps the first distribution is for females and the second distribution we have here is for males. And this is showing us the distribution of height for males and for females. When we run a t-test, we're testing whether the mean for height for female is significantly different from the mean for height for male. Okay, so we're comparing two means here. An ANOVA we're going to use when we have an interval ratio dependent variable and a nominal or ordinal independent variable that has three or more categories. For example, maybe we're going to look at racial and ethnic differences in household income. And so we're comparing across race and ethnicity income to see if the means in income across racial and ethnic groups are statistically significantly different. Okay? So that's what ANOVA is going to be doing for us. It's comparing 3 or more means, whereas a t-test is comparing 2. That's as much as I'm going to give you here. Just know that if you have a dichotomous variable and an interval ratio, you're going to do a t-test. If you have a nominal or ordinal variable and an interval ratio variable, that's when you're going to do an ANOVA. Now I want to give you a chance to actually see what running a t-test looks like in SPSS. So you do have a video here. It's from the same Research by Design video series, and you're going to observe running a t-test in SPSS. So watch that video, the link is on Inquire, and then answer the following video question. In the example you see in the video, what are the null hypotheses? And there are 2 because you ran 2 t-tests. Based on the p-values from the t-test in the video, do we reject or fail to reject each of the null hypotheses? Explain your answers. Okay? And I do also want, before you get into watching this video, I do want to also note that we didn't discuss t-values, critical values, confidence intervals, and all that in class. We only discussed p-values, so focus on this part of the video, and you might learn a little bit extra in hearing about t-values, critical values, and so on. Okay? So you can pause here, watch a video, and answer this video question on Inquire. Let's move on to non-parametric inferential statistics. And non-parametric inferential statistics exist because we can't use the same test. We can't use a t-test or an ANOVA when we don't have an interval ratio variable, because we can't make the same assumptions about the distribution of our variables. And therefore, we need some different statistical tests that we're going to use when we have combinations of perhaps nominal variables, ordinal, dichotomous, those that are not interval ratio. Okay? There are 3 tests that I do want you to know, or at least know when to use these tests in order to gain some inference. And we're using inferential statistics still, to gain some inference about whether our findings generalize to the population. The 3 tests we're going to go over are the chi-square test. We're going to spend the most time with the chi-square test, the Whitney or the Mann-Whitney test, and then the Kruskal-Wallis H test. And I do have right here on the slide when you would use each one. So do know this, be able to apply this when given an example. We're going to go into a little bit more detail in the next few slides about chi-square tests. Let's talk a bit about the chi-square test. And let's say we are looking at sex differences, or perhaps potential sex differences, in attitudes toward the legalization of marijuana. Let's say that is our research topic, our research question. First thing we're going to do, well, after we run our univariate statistics to describe each of these separately, we're going to run our crosstab, or our contingency table, in order to just eyeball the kinds of differences, sex differences that we might see in this case. All right, so we have respondent sex in the columns. We have attitudes toward legalization of marijuana, legal or not legal, in the rows. And I also put in the column percentages here so we could more easily just eyeball the differences that might exist in attitudes toward legalization. And if we look at the table, we have for males, 65.9% are saying marijuana should be legal. If we look at females, 57.2% say marijuana should be made legal. And then we can just look on the flip side, 34.1% of males say not legal, compared to 42.8% of females. So it looks like there may be some pretty substantial difference here, right? But we want to know if this is something that we can generalize to our population. And we're going to run our chi-square test to do that. So I wanted to quickly mention, practice our null versus alternative hypothesis. Our null hypothesis here is that there is no sex difference in attitudes toward marijuana legalization in the population. That's our null hypothesis. And we're going to run our chi-square test to determine the probability that we would get these results here if our null hypothesis was true. And then if the probability of that is less than 0.05, meaning there is less than a 5% chance we would get these results if the null hypothesis was true, then we're going to reject our null hypothesis. Okay? So here's our contingency table. The next slide, I'm going to show you the chi-square test output from SPSS. Here's our SPSS output for the chi-square test using the same variables from the previous slide. So we're looking at sex differences in attitudes toward marijuana legalization. And what we see here is a lot of values here. I really only want you to pay attention to a couple of values. So 14.515, that's our chi-square value. Generally speaking, the larger the chi-square value, the larger, or I shouldn't say larger, the more confident we can be that there are some significant group differences here. But the one that we're really going to use to determine whether or not we should reject our null hypothesis is under asymptotic significance. That's the fourth column over in the Pearson chi-square row. And what we see here is a value of 0.000, so very small. That's our p-value. Okay, our p-value is less than 0.001, 0.000. This means that we would conclude that we're going to reject our null hypothesis. We're going to reject our hypothesis that there is no sex difference in attitudes toward marijuana legalization in our population, and instead conclude that there is a statistically significant sex difference in attitudes toward marijuana legalization in our population. So we're going to reject our null hypothesis. This confirms our alternative hypothesis. There are a lot more values here, as I said, but for our purposes, really you would just focus on the p-value to determine whether or not you do have that statistically significant relationship. And I also don't want you to forget these other non-parametric tests that come in handy when we have particular combinations of variables. For the Mann-Whitney U-test, we're going to use this when we have a dichotomous independent variable, an ordinal dependent variable. This is a non-parametric version of the t-test, right? Because we have an ordinal dependent variable instead of interval ratio. Finally, the Kruskal-Wallis H-test, this is when we have a nominal or ordinal independent variable and an ordinal dependent variable, and this is the non-parametric version of the ANOVA, right? Because we have our ordinal dependent variable instead of an interval ratio variable. Okay, so do remember these as other non-parametric tests that you could potentially use depending on the types of variables that you have. Now I want to give you a chance to see how a chi-square test is done in SPSS. So you're going to watch another Research by Design video called Chi-Square in SPSS. The link is on Inquire, and then I want you to answer the following video question. In the example you see in the video, what is the null hypothesis? Based on the p-value for the chi-square test in the video, do we reject or fail to reject the null hypothesis? Explain your answer. So again, more practice with hypothesis testing. I want you to see how to do a chi-square test in SPSS because we're probably not going to actually be using SPSS independently anymore in class, given all the issues with connectivity we had. But I at least want you to see it. So you can pause the module here, answer this video question on Inquire, and then come back for the rest. Lastly, I want to show you our table. This might look familiar. This was in your PowerPoint module last week, or actually 2 weeks ago, when we were doing bivariate analysis and tests of correlation. I added another column here, actually 2 columns here. The inferential statistics column to test group differences in the population. This is indicating, based on the combination of variables that you have, what kind of inferential statistical test you would use. And then at the end, I also have parametric or non-parametric. So you can use this table as a guide, as a reference, when you're trying to figure out what statistical tests you should be doing for an exam or for your research proposals. This will come in handy. Okay, so just wanted to give this to you to use for yourself. Here's your closing question. What kinds of bivariate inferential statistics, maybe there's one, maybe there's more than one, would you use to conduct your proposed research? So the research that you are writing about in your research proposal assignment. Name the specific tests you would use and explain why you would use these tests. Okay, so you can pause the PowerPoint module here, answer that closing question, and then come back for the final slide. That concludes your last PowerPoint module for this semester. Here's what's coming up soon. First, you don't have any assignments due this Friday because we pushed the full research proposal to the next Friday. You also don't have any readings for next week. Next week was supposed to be for presentations. I will figure out something to do with our last week. Mainly, I want it to be a time of reflection of what we've done throughout the semester and how you might take what we've done and apply it outside of the classroom. That's what we're going to be doing and discussing next week. As I just mentioned, next Friday you have your full research proposal due on Inquire. All right, so I will see you in class this week. We're meeting both on Wednesday and on Friday.